right, this is an example of a rates of change. So along the side is a land and sea profile where the x-axis is your sea level. The function is given to us, gives the height of the land or seabed in relative to the sea level at distance x kilometers from shore. So go ahead and look at the graph. So here is your x-axis. Then you have your y-axis. So the height is your y-axis in kilometers, where the x-axis is your sea level. And then you'll see that we have our curve denoted in the blue. So here is our function graphed out. So part A says, find where the lake is located relative to the shoreline. So we're going to set that equation equal to 0 and solve for x, finding those critical points. So we would take 1/10 x equals 0. Well, we get x equals 0. So here is a ordered pair, 0, 0. Then we would do the next factor of x minus 2, set it equal to 0 and solve for x. So this would be over 2 up 0. And then the last one, x minus 3 equals 0, so x equals 3. So that would be that last point, 3, 0. So from the graph, we can see that near the part of the lake is 2 kilometers from the sea, and the farthest part is 3 kilometers from the sea. So this distance here is 2 feet from the sea, and then here is 3 feet from the sea. All right. Part B says find the derivative function and interpret it when the value is x equals 1/2 kilometers and x equals 1 1/2 kilometers. So what we have to do is we have to take that equation and convert it to standard form. So we first need to FOIL those two binomials. So what we're going to get first outside, inside, last. So there is a quadratic. And then we need to distribute this 1/10 into all of those terms. So we're going to get 1/10 x cubed minus 1/2 x squared plus, there should be a plus here, got my mistake, 3/5 x. So I'm multiplying by 1/10 and then I'm simplifying those fractions. So that is our equation in standard form. Now we're ready to find the derivative. So we'll bring down that 3, so we get 3/10 x squared. Bring down our 2, so 1/2 times 2, those are going to cancel out. Drop the power. So our derivative function is 3/10 x squared minus x plus 3/5. Now we're going to go ahead and substitute 1/2 and 1 1/2 in for x. And then we would just use our calculator to simplify that. And in that first place, when we substitute 1/2 in with our calculator, we're going to get 0.175. So what that represents, it's the height of the hill as it's increasing when x is 1/2 kilometers. That slope is positive, so the land is sloping upwards at that point. So if we go over to 1/2, so here is about 1/2 on the x-axis, that slope is what we just found. We found the slope of 1/2 kilometers away. So that slope is 0.175. So that's the slope at x equals 1/2 kilometer away from the sea level. Now we're going to go ahead and find x equals 1 1/2 into the derivative function. And then we'll use our calculator. And what we get when we're done simplifying that is negative 0.225. So what is that representing? That is a negative slope. So that's the slope at x equals 1 1/2 kilometers away from the sea level. So let's go up and show you that on the graph. So here would be about 1 1/2. That slope, you'll notice here, is a negative. Going down, it's decreasing. All right. Part C says the deepest point of the lake occurs when the slope is 0. So we need to find that depth. The slope is 0. So we need to find out when is the derivative equal to 0. So we can show you in the graph here, when is the slope 0? So I'm just going to maybe change this to pink. So when is this slope right across here 0? So we're going to set our derivative equal to 0. So our derivative was 3/10 x squared minus x plus 3/5, and we're going to set it equal to 0 and solve it for x. So one way we can do this is we could use the quadratic formula to solve it. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a, or we are allowed to use our graphing calculator. And how we do that is we can substitute this equation into our graphing calculator and find the zeros where it crosses the x-axis. Those are your x-intercepts. And when you're done, you're going to get 2 answers. So the x-intercepts for this function, there's 2 of them. You get x equals about 0.785 or 2.55. So what we need to do is go back and look at the graph. Which one of those would make sense in our image? So if we're at x equaling 0.7, that is not a slope of 0. But if we go here, it's somewhere between 2 and 3 is that deepest point of the lake. So our answer would be x equaling 2.55 would be the deepest part of that lake. So now what we need to do is find out what is that depth? What is that y? So let's go back down. So the deepest part of the lake is when x equals 2.55 kilometers away from the sea. So how do we find that depth? We're going to let x equal 2.55 into the original equation. So we're going to substitute 2.55 into the original equation. So 1/10 x 2.55 parentheses 2.55 minus 2, and then 2.55 minus 3. And then we would just type that into our calculator. And what we get is approximately negative 63.1 meters. So how deep is that lake? That is 63.1 meters is the depth, because it is below the x-axis. So sea level would be 0. It is below, so it's 63.1 meters in depth when it is 2.55 kilometers away from the sea. That's the depth of that lake.